Hello, everyone. Welcome to this webinar on data science. This webinar is going to be a guide to get you started in your data science learning journey. Whether you are a fresher or an experienced person, technical or non-technical, whether you like Power BI or you like Python or you don't know any of the tools, whatever the case is, we will try to demystify the journey of learning data science for you. Hi, my name is Manu. I'm founder of KlayMatrix Data Labs. I've been working for almost 17 years in this industry, training many individuals every year, be it students, executives, senior management people, and the likes. So let's begin and try to understand how we can get started and where to start from in our data science journey. So in this webinar, we will briefly cover where to start from, the various data science roles that are available to us, the data life cycle, how the data flows from the start to the end, the types of data analysis that are carried out, and finally, the way ahead. Whenever anyone starts his or her data science journey, there's so many terms and things that come across, and one gets confused what is right, what is wrong, and which one suits him or her the best. So there could be things like, which tool should I use? Should I use Python or Power BI? Which role gives me more salary? Which role gives me better chances of promotions? So on and so forth. There are also questions around which platform to use for learning. Should I go and just learn from YouTube channels? Will I enroll to a course? Or will I do a mixed bag of things? So though there are no fixed set of rules, everybody, depending on their constraints and requirements, can follow a given path. But through this webinar, we will also try to demystify a few of the points over there. So it's pertinent to understand the roles in data science before we actually start to dig deeper into the points around the data science learning trajectory. The roles that are generally available in data science universe are data scientist, data analyst, data engineer, ML engineer, and BI developer. Now, each of these roles do a specific task. For example, a data scientist works with advanced analysis, works on ML models, evaluates them. A data analyst, on the other hand, will look at the data and visualize something interesting from that for the purpose of reporting, drawing insights of the data, so on and so forth. A data engineer, on the other hand, would link up data from different sources. For that, he or she will create data pipelines, integrate multiple systems, create storage spaces, and then provide that in the form of a data lake or a data warehouse or just a database as well. An ML engineer, on the other hand, would help in the model deployment. So if a data scientist creates an ML model, how do you deploy it online in your application or in something which can be accessed by the outside world? So that's the task of an ML engineer. A BI developer, on the other hand, as the name suggests, is a business intelligence developer. He or she works around creating dashboards, getting insight from the data, and creating reports which could be targeted at different levels, functions, and domains. Now that we know the roles in data science, let's also talk about the data lifecycle. Now, once we know how data flows from start to the end, we would be able to relate more to the various roles, the various tools that are required, and the entire ecosystem of data science in a better way. So our data lifecycle starts from the data source, which could be structured or unstructured. Some of the examples of these data source include your usual Excel or text files, databases, which are generally relational databases, and are driven through SQL. The next in the data lifecycle is data storage and processing. This could include data warehousing, modeling, storing, and cleaning. Some of the examples of data storage and processing include Microsoft Azure, Amazon Web Services, SQL databases, Python, and R. And next, and the final layer here is the data consumption layer, wherein we use data from the storage and processing layer to create AI and ML models, create data visualization in the form of dashboards and reports. And for this, we use Python, R, SQL databases, tools like Azure ML, and many more. Now, this is a generic overview of a data lifecycle or the architecture full stack of a data lifecycle. Now, there could be multiple sub-layers that can be brought in depending on how intricate your requirements are. But this webinar is more for beginners. We have given a very basic overview of a data lifecycle. Let's also talk about the type of data analysis that one has to do when doing data analysis in the purview of data science. So first and foremost is descriptive analysis. It uses historical data. It understands what has happened, and as the name suggests, it describes the data. We use charts and basic statistical method to do the descriptive analysis. Next is predictive analysis. It uses historical data to make predictions. Some of the methods that are used include forecasting and risk assessment. Exploratory analysis, on the other hand, uncovers patterns within the data. For example, if you have a time series data, you might want to see what is the seasonality, what is the trend, is there any pattern, is the sales rising in a specific month or day of the month, so on and so forth. Some of the tools or methods used here include data visualization and clustering. Then is diagnostic analysis. It investigates with data why something has happened. It identifies patterns, trends, and anomalies. Some of the methods used here include drill down and root cause analysis. Next is prescriptive analysis. Here we recommend actions based on the predictive analysis. So for example, if you foresee that the sales are going down, you might prescribe that let's spend more on the marketing. Optimization algorithms and simulations are some of the techniques that are used in prescriptive analysis. And finally, we have inferential and text analysis. Here, some of the examples include making inferences about a population based on sample data. Also, extracting underlying sentiment from the text data comes under this analysis. So, how do you plan your learning in data science given all these points? So there is again no fixed path, but what the slides talk about is to give you a basic path to follow, and then from there you can build it up. So at the very beginning, and if you're a beginner, you can start with learning the basic concepts in statistics and mathematics. For example, center tendencies, standard deviations, variance, various distributions, and tests, so on and so forth. Next comes learning different tools. You can learn tools like Excel, Power BI, Tableau, Python, R. You can also learn about various cloud systems like Azure and AWS, or a query language like SQL. Now, which tools to learn and which not, or shall we use all the tools, depend on your requirement and the overall end objective. For example, if you are a research person, maybe in academia, or maybe you are doing some research in some development sector, maybe R is something you might try as a programming language. Whereas if you're developing an application for some business, Python could be a good choice. Again, Python and R can be used interchangeably, but what we're saying here is many times R has been used for academic or research purpose. Python is more in sync with developing applications and tools for business requirements. Power BI and Tableau, both are visualization tools. Which to pick, again, depends on your requirement. If you are looking for a more Microsoft ecosystem-driven thing, then Power BI is your tool, because Power BI is a Microsoft tool. That doesn't mean that Tableau does not work in Microsoft environment, but since Power BI is a Microsoft offering, it gels well with the Microsoft ecosystem. Tableau, on the other hand, is very high on the quality of visualization and has some advanced features as well. So depending on, again, on your requirement, you can choose between Power BI and Tableau. Once you have got a basic understanding of statistics and you're hands-on on some of the tools, you can parallelly, or maybe after some time, start practicing using some online quizzes, exercises, case studies, competitions, and hackathons. And finally, you can conclude by doing some projects, which can come through internships, freelancing work, online problems, or maybe small gigs. Now, how much time each of these take, it really depends on how much you want to go deeper into each of the topics. Generally, learning in basic stats can span anywhere between 1 month to 6 months. Learning tools like Power BI can take hardly a month, but if you want to get into deeper details like DAX, Power Query, and other stuff, then obviously the time goes up. Similarly, there is no limit to how much you should practice on hands-on and doing projects. But ideally, if you do a 6 months to 1 year project or internship, that should be good for you. Just to give you an idea about how much it takes to learn these tools, again, this is not a fixed rule. Different scenarios can take different effort and time. But in general, Power BI and Tableau are easy to learn as it needs less of coding and technical skill. So if you are low on coding or you're just starting to code, Power BI and Tableau could be a good place to start. Python is a programming language and its initial learning curve is quite steep. But once you get a hang of it, the learning becomes relatively easy. The other benefit here is once your foundation is strong in Python, you can learn different aspects as separate modules. For example, if you have your Python foundation strong, you can separately learn about pandas library or a scikit library or a visualization library. Likewise, you can learn statistics separately, machine learning, so on and so forth. Next is SQL. SQL is a query language typically required to work with databases. A moderate level of learning is required here. Depending on the role, for example, whether you have to create a database or you just have to access data from a given database, you can plan your SQL learning journey. And finally, Excel, though it's one of the oldest data tools, still is live and kicking. The real fun lies in getting deeper in your Excel journey. For example, if you want to understand functions in Excel or using DAX and advanced queries and maybe Power Query in Excel, that's where the challenge lies. In short, as you can see, Power BI is relatively easy to start with, so anybody can pick it up and wrap it up in very short time. Python is more from coding or programming perspective. It's still relatively easier because it's more English-like than other programming languages. SQL, if your role requires, it's good to have. I recommend anybody who's planning a data science journey should have a basic understanding about SQL. And Excel, I think this should be one of the starting tools for everybody who's taking the data science journey. Having said that, let's also try to understand how much of these tools one needs to learn based on the roles. If you're targeting a specific role, you might want to have an advanced level, an intermediate level, or a basic level of understanding of these tools. So let's see what it takes in each of the role vis-a-vis the tools that are available. So for a data scientist, Python, machine learning, statistics, SQL, these are some of the tools. Mind you, these are not the exhaustive. There are few other tools as well, but these are the essential tools for a data scientist. Excel and Power BI are good to have at intermediate level. For data analyst, Power BI or Tableau, Excel, and SQL are essential and should be known at advanced level. Python and statistics can be learned at intermediate level for data analyst, whereas machine learning is relatively not required for this role. Data engineer should be very high on SQL. Some of the other tools that data engineer can and should learn include a good understanding of other tools like the Microsoft ecosystem for creating data lakes or data warehouse, or maybe through AWS also. There's also a good tool or place to start with. There could be other tools like RPA, Thor machine, or data cleaning tools. So again, it depends on the use case, but yes, SQL is something a data engineer should really know. And then these are the tools that would need an intermediate level of understanding for a data engineer. Power BI and Tableau, generally, a data engineer would not need. For a machine learning engineer, these are the tools that are required. Excel at intermediate level will do good for a machine learning engineer, whereas Power BI and Tableau are generally not required for this role. A business intelligence developer, on the other hand, needs a good knowledge of all these tools, an intermediate one for these, and maybe not that much in machine learning. Every year, a lot of people start their data science journey, and very few of them actually reach their goal. So what differentiates successful ones from the ones who fail to complete the journey is a proper planning and continuous hard work. So we have fragmented it into 3 components: explore, practice, and apply. In the explore phase, the new beginners in data science journey would look into various websites, YouTube, maybe talk with their friends, discuss there, join webinars and workshops, join some courses, and explore various courses, tools, and roles. Next is practice, wherein they practice again through advanced classes and online or offline courses, do case studies, and solve problems. And finally, apply the learning using hackathons, competitions, internships, assignments, and projects to build a robust foundation in the data science knowledge. If we follow this path and add a little bit of hard work and practice to it, we can surely succeed to reach the desired goal. To help you further, we have created 3 roles with specific kind of requirements. For example, if you are high on analysis, but not that great in coding or data or designing data flows, then probably data analyst or BI developer is a role best suited for you. Whereas if you are good in data flows, which means you are good at creating data connectivity, linking multiple data sources together, creating databases, and have an average understanding of analyzing and coding, then probably data engineer is a role for you. And if you're good in coding, analyzing, and maybe not that great in data flows, then maybe being a data scientist is a role for you. So this is a very high overview of what these specific roles need in terms of 3 basic traits, which is coding, analyzing, and data flows. Now again, this might vary depending on different requirements. This is just a very high level information. So hope this helps you to understand different roles, what it takes to get into these roles, and also what level of learning is required under each of these tools. So you can start your journey and proceed with this help from this webinar. Now, I would like to spend some time on explaining how we at KlayMatrix Data Labs can help you to enhance your data science journey, specifically if you are just starting this journey. So to begin with, I'd like to talk about where all we have worked. These are the past clients. As you can see, we have been working with academic institutions as well as other organizations and corporates. Our training offerings include self-paced courses wherein we host our courses on a dedicated LMS portal and one can learn at their own time and pace. We also have our online live mode wherein a live instructor delivers online sessions. You can join our online sessions in a location constraints. Then is the offline mode wherein we have the live instructor-driven sessions on your premises. It is better in terms of communication because here we have a face-to-face interaction between the instructor and the participants. And finally, we have the hybrid mode, which is a mixed bag of all these possible delivery modes. Needless to say that certification, LMS portal, pre-account, hands-on projects, and many more things are part and parcel of each of these offerings. So our trainings include certification. We do carry out case studies. There are team presentations during trainings for teams or groups. We do training at academic level as well as corporate level, workshops, hackathons, and many other such things are part of our training module. Currently, we are delivering training in these modules and few more. We can customize your training requirement, add new modules as per your requirement, and deliver it to enhance your overall data science journey. So I hope you found this webinar useful. If you still have questions, you can reach out to us at support@KlayMatrix.com. And if you can see or have access to our form, do fill it out because our team can access it and then give you some value add suggestions based on your submissions. So don't forget to fill in the form and our team will reach out to you shortly. Thank you so much. Have a great future ahead. And if you wish to follow your data science journey with KlayMatrix Data Labs, do reach out to us. This is Manu from KlayMatrix Data Lab signing off. Thank you.